All right, are we live? Should be live anytime now. Yeah, I think we are live now. Perfect. I'm gonna let people join. I'm gonna let people step in thoda, and then we're gonna start. Hope my voice is fine. Everyone can hear me. Gonna give it some time. It's been a long, long time, guys. I don't know. Hi Nihal. Hi Yar. How are you doing? I don't know. Again, I'm back to 1.45k subscribers. Every time I stream, I lose subscribers. It's a gentle reminder how things go. Areva, hi Bhaiya. What is this crown that comes in? Are you a subscriber or something? Have you? Oh, yay. Uh, Give me 1 second, guys. I'm gonna do a quick mic check. All right, guys. Cool. I'm still gonna give few more minutes before we start. So this is like something I've been thinking about. When we used to use this KDN Live, if you guys are aware, this is the video editing software available on open source, available for Windows and Mac as well, not just Linux. Um, oh, is it changed to something else? I don't know. So they've renamed it to something else, is it? Not sure. I think they did, or maybe I'm just looking at the wrong one. Yeah, there you go. This one, right? So this is something that I've been fascinated by, and I was thinking that I should build something like this for myself, right? I would like to imagine how video editing works. Now, given this involves a lot of pre-processing, post-processing, and a lot of optimization, apart from just the graphical user interface. Uh, so why not start with something very basic, something like, camera filters. How can we build them? And if you guys are aware, we do have a blog over here where we did work on something similar some few years back when I was young. Now I'm not. Ta, 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 ta. Yeah, there you go, right? So when I okay, I used to look, yeah, like this. Okay, no shame, but how you would crop a circle was something very interesting to me because eventually every pixel is essentially a rectangle, right? Because if you look at it, it's a number, right? And when you start looking at a cropped surface, it's essentially a rectangle only, right? So how would you crop a circle? And eventually you don't. It's just like when you smoothen out the curve, it becomes a circle, right? It's over here that you see in between. This is not really a circle as well, but it looks like a circle because we are not zooming in further, right? I mean, yes, it's a circle because the background is transparent, but eventually still it's a cropped rectangle. Hi, who is this handsome gentleman? Okay, thank you. I don't know about handsome, but yeah, gentleman, I'm pretty sure it's me. That's something I can be very confident about. But hey, welcome to the stream. It's your first time, so uh, I'm sorry to. What's your CAN name? 2077. Not sure about gentleman. No, I'm pretty sure about gentleman. No, like I'm not sure about the handsome part, but yeah, gentleman side, yes, I'm sure. But cool, right? So this is something that I used to do before, and I was thinking like we should continue and build something up on the top of it. Must be Dev. Okay, hi Dev. If you're Dev, welcome to the stream. Guys, if anyone is here, they want to say hi, please say hi. If it's your first time, don't feel weird. Don't feel um, uh, I don't know, just overwhelmed. Just say hi in the chat and let's continue. Anyways, so this is something I've been thinking about. How would you do all of it? YC funded many video editing software this cycle by the way I focused. Yeah, I mean, see, videos are the new way to reach out to people, right? Essentially, not everyone is looking at text, they're looking at images and videos, and that too, very short videos, 15 seconds, 20 seconds, right? So, how can you build something that is within a few seconds? You don't have to spend money and time and efforts in explaining to a video editor that, hey, I want things that way, right? So, quick marketing is something that people are focusing on, that's for sure. So, how can you do it faster, better is something. Yeah, a lot of startups would be interested in. So, I mean, I'm pretty sure that you guys know of this guy. He has been building his own video editor. So wait a second. I'm pretty sure. I think he was building in Zig, if I'm not wrong. Let me go to his GitHub quickly and try to find it, right? So this is his sponsors page. I think I'm pretty sure all the developers who follow him must admire him at this point. Yeah, so there you go. He was building a video editor in Zig, right? And he has been doing it for quite some time. So I'm pretty sure it's a long project. Okay, he has stopped working on it, I guess. That's a rest in peace. Mm, this is a far enough along that I was able to use it to experiment with my use case, cutting down Twitch videos into something shorter. I found that I didn't like any of the cuts I was making, so I've lost interest on progressing this further. Further, no further development is expected, but please feel free to continue on if you think it's valuable. Right. So, I mean, of course, right. It's a long shot. You can't really use it in production. And for someone like him, if he was not able to do it, so that's not a demotivation. That's a motivation for us to build something. So I don't want to get into the graphical user interface of it, right? So one thing I've always realized is when you go to a badminton game and you are like, okay, can I get clips of my smashes that I played, right? How can you automatically get the relevant clips is something I'm very interested in, right? And there's not much AI into it. There's some mistake we always do that we think of AI that okay, there'll be some AI into it. No, you don't need AI over there. All you need is pattern matching, right? So this is something that I've been thinking about as well. Uh, I think let me get the chat into the main pop out chat. Ta-da! Now you guys are over here. Okay. So yeah, I've been thinking about it, right? So how would you do that specifically? It's very easy if like all you have to do is I think there's been let's open Perplexity for once and so let's ask it. There used to be some audio pattern matching algorithm. If I'm not wrong, there was this thing. Uh, no, this distance matching is what I'm looking for, not really audio pattern matching over here. Yeah, some cross correlation that you can. So STFT or filter banks, not really looking for something. So yeah, we used to study all of that when we were. Hi YouTube, yes, hi YouTube. Hi everyone. Sorry, I kind of hit the chat. Yeah, wait a minute. Distance matching algorithms. Right, so let's don't hide the chat, boy. How you been? Hi Jaideep. Yeah, it's been a long time without you, my friend. I've been good. I've been good. Sorry, I was just I need to figure out how to make it on the top, always on top, wala cheese. So yeah, I'm still getting used to it. Yeah, welcome, welcome, welcome. I've been good. I've been good. Yeah, thank you so much. It's really good to have you here. How's your work? How's everything? Yeah. So Levenshtein distance and its variants, I thought they are always relevant to. Okay, I never thought that these. Yeah, I always thought these are edits between strings, widely used for spell checking. Yeah, I'm not looking for this. Okay, for this, I'm looking for. So yeah, maybe the kind of things we used to do. Let's see for audio signals. Right, let's check. Yeah. So I'm right now looking for something that is audio pattern matching and audio distance. Yeah, MFCC is something I don't remember the full form, but it wasn't really English as well. Yeah, if I remember, MFCC was not really mel frequency. Yeah, yeah, this is not English for sure, but this is something that you could use. Is a set of features to use to represent an audio signal's short-term power spectrum, widely applied in speech and speaker recognition, right? So at that time when AI, Gen AI wasn't really there, and people used to really focus on mathematics of everything. This was very beautiful. So we did use this in a bit in our college project. So I was thinking we could reuse this, right? Have this FFT calculated and then find the features and then try to find the distance between all the features. So essentially the way it works is, suppose you have a tap water going on, right? And what you want is you want to figure out how many times the tap has been opened. How would you do that? right? So you will have a reference feature. You will say that, okay, there's a feature one. So let's go to Z editors. I've been trying it out today. So let's save it as probably audio feature matching.md, right? So this is from the stream, audio feature matching ideas, right? And so very first thing is, suppose you have a, let me just zoom in for you all. So you have a feature 0, that's a reference feature, right? So what you would want is that from this feature, there's an audio signal, right? So this audio signal has, let's say you take a window of every 3 seconds, okay? Because if you imagine, like, a tap will generally run for 3 seconds, 1, 2 seconds minimum, right? Unless until you have some fast hands to make it run for 1 second. But anyway, so you will generate features out of it, right? So you will, of course, you will do some probably transformation on the top of it, um, right? And this is, I'll rather call it a window. And then you will generate features out of it. And what you will do is you will compare F1 to Fn with F0, right? And whatever feature that matches, you will use some distance matching over here, right? So whatever feature that is close to the feature that you have as a reference feature, like I can call it fref instead, it's if that's easier. And for once, just imagine this is f0 to n, right? So okay, I don't know why I'm being very picky about it. But okay, so whatever features that really match the reference feature is the windows of every time a tab was opened, right? So this is a very interesting time, like interesting problem to solve, right? And what you can do is, now this every time a tab was opened is essentially like represented by fref, right? So you really don't need to worry about whatever you want. You can just have a window as a parameter. So you will have two parameters, right? Inputs will be, one will be a window size, I would say, window length, right? And the other would be fref, right? So this will be whatever window you would want to compare with, right? And that's something that you can do as using these features, okay? So now it's very interesting thing to build, right? And what I would want to do is imagine that you are playing, probably let's say you are playing badminton, okay? Now you know there are multiple references you have of smashes sounds, okay? So there could be some very hard smash someone has made. There could be a very probably a drop shot, whatever you want, right? Or some smash from far behind, some smash from very close by to the mic and all. So there would be different frequencies. There were like different uh, voice signals that you have, right? So this is what you will have, and these are essentially features. These are, even though these could be an MP3 or WAV files, but you will convert them into features, right? So now what you would do is you will have a badminton video, right? And you will probably have a window size and all the features, like we will call this fref 0, fref 1, and so on, right? So this is what you have, and then you have the feature vector, right? Ref feature vector, right? And you can also probably have a distance algorithm, like it can be just a callable, right? That you will call with the inputs that you have, and this is a distance callable, right? So what you would essentially do is you will pass it and say that, okay, return me the smashes videos, and what I would want is, let's say, output window length should be of, let's say, uh, uh, 10 seconds, right? And why is that? Because of course, when you have hit a smash, you would want the video to be slightly longer so that you can post on Insta, and also you can also have it on 15 seconds. So how would you do that is a very simple problem to solve, and of course, we'll experiment further on this, but let's see if we can do it, right? So this is very interesting. And this is what I want to build with an editor. It's not just like camera in terms of image processing, video processing. Video processing is essentially image processing with one more dimension added. That's a time frame, right? So what is a video? Set of frames, right, over particular space and time. Like I think time, right? If Bhaiya is here, he'll confirm. But right, so you have one added dimension of time. So frames are moving with time. That's it, right? So this is like just as simple as this, a vector of frames, and that's where you add one more dimension. So that's simply image processing. But this time we probably will be doing audio processing, and that's also like nothing different. So we will probably start with audio processing today. If you guys agree, does this sound like an interesting problem to solve? Do you want me to solve this, guys? See, we have around 15 minutes before we hop off. So today, I really want us to start working on this. So I would really not be coding this stuff because I don't think solve hunger. Yeah. भुजिया खाओ यार एंजॉय करो ये सब कहाँ like just have high protein bhujia, roasted bhujia, uh, no trans fat bhujia. Yeah, you're talking to a Rajasthani how to solve hunger. See, we have problems with water, we don't have problems with food. High protein bhujia. Yeah, this bhujia is high protein. Come on, that's not. What do you mean? Bhujia is high protein. Yes, this people don't agree is the problem. Wait a minute. I don't know why my Z editor is not opening. Yeah, there you go. By the way, can name 2077 is this Dev or not? High protein bhujia. Damn, it's true. It's true. Okay, you guys. Okay, fine. You search about it. I don't know. You guys don't. Okay, yes, it's me. Okay, perfect. Hi, Dev. What's up? So I was also reading a bit about Laplacian filters. I don't know how you pronounce it, but this is also very interesting. So we'll be doing it in next stream, right? And for what it's worth, this is one of the most interesting. You search and show the world. Okay, bhujia high protein. I also did a search about does bhujia have high. Okay, so baked protein bhujia, 10 grams. That's a lot. 21 grams natural protein. Okay. And so per 100 grams you have. Okay, first of all, can you please get rid of signing me up? I'm on a stream, so don't. Da, 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 da. Okay, did I? Okay, I just need to get rid of. Should I get rid of this? Yeah, there you go. I don't like this as well. So, da-da. Nice. So, just press close, stop showing off. Oh, close. Oh, there was a close. No, there was no close. Oh yeah, okay, sorry. I was zoomed in, that's why. No, that's why yaar, I didn't mean to. It's not interesting anyways. So per 100 grams, you get 21.9 grams. Bhaiya, if you're around, take a note. I think this is amazing. So carbs are 49.8 grams, 446 kilocalories, which is not a lot. So I think you guys should consider this. Uh, Although I'll have Bikaneri bhujia, which has probably 6 grams protein rather than this. But yeah, anyways, doesn't why do we divert from this? Actually, really good. Yeah, actually, like I didn't know this exists. And this high fiber, uh, and of course, this is 10 grams protein, 223 kilocalories. That's not a lot. So I would say, um, yeah, it's good. It's good. Guys, by the way, if you're here, do like the stream. I keep forgetting to do the needful, but yeah, please. Mm, okay. All right. Okay. Cool. Chalo, let's go back to coding. Okay. I think this is enough. How many of you are aware of Sobel X and Sobel Y filters? Like, are you guys aware of this? And how many guys, like how many guys and girls? I don't think there are any girls there. But how many of you guys are? I mean, no, I'm not being racist, but no, it's not racist, right? I'm not. So my stream has generally has 100% male audience, for whatever reason. Your GF is likely here. कुछ भी कुछ भी बोलने का मतलब है ना. Jeeks, this is okay. Okay, चलो ठीक है. Let's skip the GF talks, guys. Okay, let's come to the real world problem. Okay, we are trying to solve some patterns. So what I'll do now is, okay, I'll just copy this, and what I'll say is, I'll ask Cloud Code to do this for me because it doesn't make sense for me to do everything. Online buying innocent streamer. What the online bullying in it? Oh, okay. Like, okay, interesting. Can you write a code for me? with the above cloud code buddies. Yeah, I like it. Like, I mean, Z has been good so far. So I was just trying it out with the above intention in mind. I would like to use MFCC to begin with. So and OpenCV to read a video, extract audio frames. I don't know if you can read a, yeah, you can read a video using OpenCV, right? If anything is not possible, point out and ask for alternatives. So I would like it to ask me instead of it doing it itself. So let's see what it can do, right? चल के तुझे मैं लेके चलूं. AMP is on Z as well, right? I think AMP did release a protocol or something, if I'm not wrong. AMP, do you have the link of it? I forgot. मैं लेके चलूं एक ऐसे गगन के तले. Z released that protocol, right? Yeah. Oh, Z released that, is it? I thought this. Okay, yeah, probably Z released this. Yeah. Oh, yes, yes, yes. They have their inbuilt, but that cost, right? If I'm not wrong. Yes, 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 yes. Yeah, that's right. Fair enough. Mm, so let's see what it did. It will surely be asking me always allow. That's not an issue. I don't know why, like whenever I open cursor, I don't want to write code, but with Z, I really like writing something as well. There's some thing about the UI that in cursor it forces you to open the chat. In Z, it's just like do your thing. If you want to use your go edit like okay, I don't think I should talk much about this. I should skip that part. Yeah. Okay, keep reminding me guys, okay? Uh yeah. Ask me to skip these topics, okay? That's I'm So it has designed the overall system architecture, implement MFCC feature extraction from audio, implement video audio extraction using OpenCV, sliding window processing, implement distance-based. So as it is like whatever we have told, it has done it for us, right? So I'm gonna just keep all because okay, things people have to do to keep. Can you guys skip those topics? And Dave, yeah. Anyways, where were we? I'll skip to the good part. What file are we looking for? Example, badminton detection.py. I was talking about me. Makes sense. You have to do a lot of things. Thank you. You guys are amazing. If someone is reading this, it's okay. I don't think my channel has enough viewers right now, so that's all right. By the way, what are your plans? Anyone has got any plans for the weekend? Not really weekend, but New Year plans, the Gen Z plans. Jaideep, you must have plans to take your bike around, huh? Are you still playing? Are you guys still playing Counter-Strike nowadays? What do we have here? Video audio extractor. So generally the best way to read these code is let's just ensure that it has done its part. So what is it saying? So it has created audio feature matcher.py, which has audio feature extractor, video audio extractor, audio feature matcher. Okay, example badminton detection.py. That would probably take what are your plans? I don't think I have any plans right now for the new year. This time I'm gonna like I've been working too hard. Still playing. Just came from a long bike tour off to mountains for New Year. क्या बात है? Damn, this cool, huh? Bike tour यार इतना how do you do it? And which bike do you have by the way? Yaar? I was thinking to I was thinking to so how suggest a bike as well. But anyways, GT 650 don't buy that. Oh, I was actually considering that one only. Okay. Yeah, I think I should talk to you before buying then. Dave, are you continuing with the plan that you mentioned before for the new year, or do you have any change in plans? Is it too cold in Indore, Jaideep? If I remember correctly, huh? That's where you live. Hope I didn't break your privacy. So we have reference audio files, not really. For the okay, it's not really cold. Okay, ठीक है. Um, so what it's doing is over here, guys, reference smash sound files, you will need to have it yourself. So this one we'll have to do it ourselves. This is like more of a manual thing we'll have to do. Then you will load reference feature from files, and then you will have audio feature matcher. You will pass reference features, window length, threshold, uh, based on your extra New Year plans. Cancel, lol, will go sometime later in February, March. Yeah, yeah. I generally say like in the New Year, stay home, or like when everyone is traveling, it just becomes like our New Year is anyways different. Like everyone has a different New Year, right? Based on the region, not necessarily religion. So whenever you want to go, just go, right? So we have a badminton match.mp4 file that will be processed. Now, one thing I'm very interested in is what's the process video. Okay, why is this not working? Do I need to do keep all or something? Okay, 1 second, guys. Give me 1 minute, okay? I'll be back. All right, guys. Back. Sorry. 1 second, 1 second. Okay, cool. All right, so let's start with this. So we do have audio feature match over here, and I don't know for some reason the go-to definition is not working. Okay, this is one thing I don't understand about Z, but okay, I hope this works. Okay, okay. It keeps disappointing me somehow that GD is also not working. Dude, you just okay. This is possibly because of this. What is this? They don't have imports over here, is it? Okay, that's interesting. What's the file they had? I think we'll have to add RSS. Okay, let's just add this RSS. This is weird. I expected better from Z. Video audio extractor, and yeah, we will get rid of this. Yes, I've been watching this closely. This is what happens. But okay, now this works. Okay, so we have audio feature matcher, which takes reference features, list of np.nd array, right? And they have window length, distance metric, threshold, output window length. Guys, how many of you are still here, by the way? Can you just quickly say hi? एक बार अच्छा लगता है that people are still. So we are like, I promise like 10 minutes and I'll log off. So just stay here for 10 more minutes and then we are done. होला, okay, ठीक है यार. Thank you guys. Thank you. Really appreciate it. ठीक है. I'm humbled. I'm grateful. I'm thankful. Kamsahamnida. What makes you think people are not here? My general pattern. If I do my pattern matching on my channel, you will see that most of the times it's two or three people that's you guys hanging around. So yeah, but still loyal viewers here. I mean, not even I would say viewers. I think at this time you run the channel, not me. So huh. But anyways, if you guys see what we are doing is this is fine. Audio feature extractor is the basic thing we want to watch out for. So extract MFCC features from audio signals is what it's doing, right? So let's ask it now. Okay, please explain the maths behind audio feature extractor stored in a markdown file. So what I generally do is I ask it to store it in a markdown file so that we can understand how this works. librosa, yes, yeah, now this I remember. So we used to use librosa before, yeah. So this is a, I don't know if I have, mm, so we can do pip install librosa. Okay, I think it did suggest me a few other libraries as well, right? So librosa is something we used to use a lot for feature matching, and then this is the word I was trying to get in my mind because Rosa, you know, Rosa Jane Man, है ना? That song. Okay, I think I should shut up. But okay, this is the MFCC. Okay, can I do GD now? Can you please refresh your indexing, Mr. Z? Okay, I am. Okay, yeah, there you go, right? So define MFCC, so spectrogram and mel frequencies, septral coefficients. It takes a audio time series, multi-channel is supported. That means you can have a shape defined here and can have multiple channels. Sampling rate is what you can have. Long par mel spectrogram, I don't know what that means. Number of MFCCs to return. This is something that's tunable, I guess. Discrete cosine transform, don't worry about it, ECT right now. Uh, okay, so most of the times what we'll do is we'll experiment with these things, but if you see what this is doing is it's trying to load something. So see, the sampling rate is not something that you will decide. It will be decided by the reference audio files that you have. So you will get that once you load a file, right? And you will just pass it, and this is the array that you will have. Um, so I'm not really concerned about all these things now. So let's go to this file. Okay. बंठन के मटियारा आया आया पटोला बनके. Okay, I should shut up. Okay, let's preview this now. Okay, not good. Open Markdown preview. There you go, right? So let's quickly go through this. Okay, so we have audio signal, which is in time domain, pre-emphasis filter, frame blocking, windowing, which is basically just having a window of whatever time, I guess, but depending on sampling rate, it's not really seconds now, right? It's number of samples you want. Um, then you have hamming. So these are window functions that you will apply on each window. I think this is for normalizing, if I'm not wrong. FFT, power spectrum, Mel filter bank, logarithm, discrete cosine transform. Then there you get coefficients. What is it used for? Is a feature extraction technique that represents the short-term power spectrum of a sound in a way that mimics human auditory perception. Yeah, this is very interesting, right? The way you perceive an audio file is how MFCC coefficients also work, right? So what is a pre-emphasis filter? Amplify high frequencies that are typically suppressed in audio signals. Right. So I think frequencies and amplitude are inversely proportional. But yeah, if you're around, can you please guide through? But okay, let me also quickly change. Da, 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 da. This is cool. Okay. Yeah, this is nice, right? So when we are studying mathematics, we'll always stay in the light theme so that our eyes light up and we focus. So what's the mathematical formula for amplifying high frequencies? This is x of t is the input signal at a particular time t minus you do a okay, yt is the emphasized signal. You have a coefficient typically 0.95 or 0.97 and just before the xt minus 1. So this is a high pass filter that compensates for the natural role of high frequencies in speech and many audio signals. Okay, I'll quickly ask, why is pre-emphasis filter needed? Can you explain a practical use case, right? So let's talk about this as well. So keep asking these questions as you go along and then continue working. So frame blocking, of course, it's you have a frame length, divide the signal into short time frames where we can assume the signal is stationary. Okay. So of course, yes, like what you would see, this window is very tricky. Even if you like, so sometimes audio files are very hard to imagine. Imagine a video, right? And how would you want to frame a video into multiple windows is where whichever window size keeps the video stable, right? And that's how you would want to process them. So let's say if in a particular window size Dev is there, but Jaideep also comes in. Now that's something there you'll have to draw a line and say that okay, until Dev was there, there was one window. Until like Jaideep comes into the picture, that's another window that you would want, right? So this is like hop length. I think we can skip this. So the typically 2048 samples, typically whatever. Okay, it's editing the main file only. I'm gonna let it do it. Um, why overlap ensures smooth transitions and doesn't miss transient events at frame boundaries. And this is get out of my window. Yeah, don't interfere. Come on, this is not done. Okay, it has okay. Yeah, this is interesting. So pre-emphasis filter, why is it needed? The problem natural spectral split. Okay, this is interesting, right? So most natural audio signals, especially speech and voice sounds, have more energy at low frequencies. This is something I told you, right? Now you guys should appreciate my knowledge. Frequency is inversely proportional to amplitude. किसने बोला था? Wait, am I right? Okay, no, I'm yeah, I'm right. No, I'm not sure. What does it tell? So for high amplitude, you have high frequency. Okay, I thought I was. No. The power spectrum typically drops at approximately 6 decibels per octave. Uh, okay. I'll just quickly ask, is amplitude inversely inversely proportional to frequency? Is it anyhow related? Don't change markdown. Answer it here going forward, unless told explicitly. Right? Yeah. So let's see. Because I always thought like with high frequency you will have lesser amplitude. So I'll give you an example of high frequency. Hello. And this is high frequency. Use super whisper. Vibe coders can't even time these days. Arey. Yeah, the audio. Okay, so this has answered. Not in general, but yes, for many natural. There you go, guys. There you go. I was right. So for many natural audio signals, due to physical and physiological reasons, no inherent relationship is there. In pure mathematics of physics, there is no fundamental law that says, okay, let's zoom in a bit, that says what? Amplitude must be inversely proportional to frequency. Yeah, you can definitely have all these things. Is it? Super Whisper is good. I haven't given a try, but I'll give. For speech, singing, and many musical instruments, there is an approximate inverse relationship. See, guys, if my video was turned on, actually, let me turn on my video and do a mic drop, quick mic drop, okay, because this is required. I don't know how I'm gonna look like. First, let me make sure that I don't look bad. Okay, yeah. So this is a mic. Okay, drop. Okay, this is done. Okay, that was a mic drop moment. And cute. Yeah, thank you. I appreciate it. I should not turn on my video again, remind me that. But okay, so this is amplitude is inversely proportional to frequency. This 6 decibel per octave roll-off happens because glottal source, vocal cords produce a periodic pulse. In frequency domain, this is a harmonic series. Drops mic. Yeah, there you go. A pulse train has spectral overlap that falls as 1 by f. This is the Fourier transform property of a rectangular pulse. Okay, I don't want to understand all this, but overall I was right. I was right. Anyways, bottom line, there's no fundamental relationship, but Kush is generally right, is what it says. Anyway, so why this happens? Vocal tract physics, glottal. What does glottal mean, by the way? Vocal cord vibration. Ah, I see. So if, yeah, whenever you say something, it vibrates, and that's how it makes sound, right? Yeah, there you go, right? So microphones and recording chains often emphasize bass. So sounds good, right? I think we get the point. Transfer function. So you do have some transfer function that creates a high pass filter with approximately per octave boost. Effect on spectrum, this is before pre-emphasis amplitude and after pre-emphasis amplitude. As you can see, things have been normalized. Now, if you guys remember, I did tell you that pre-emphasis filter essentially helps us normalize the curve. And if I have to do a quick, so this is a mic, okay, and I'm dropping it slowly and I'm catching it now. Now I'll turn it off again. Okay, I think. So, yeah, I mean, at least from what I understand, this is how it is. If I'm understanding it wrong, it's okay. Um, so let's examine a concrete example with speech. So distinguishing S versus TH sound. Come on, it's very awesome. Okay, sit versus D or die. So spectrum of S, no pre-emphasis would be this is dominating because sit makes sense. Sit, right? Okay, weird. Now, do you have a pre-emphasis, post-pre-emphasis? Sorry, this is what? Um, spectrum of TH, the. Thy shall not drop mic anymore. Thy don't care. Keeps dropping mic. Thy likes being right. So both look similar. Low frequencies dominate. MFCC features will be nearly identical. Recognition accuracy poor. Makes sense. So what they're saying is, if we don't emphasize, oh, interesting. So what they're saying is for S and TH, the because initially it may be the energy is higher, and when you keep going to the higher frequency, the energy goes slightly negligible. And that's what is saying that MFCC features will not be distinguishable. But when you emphasize yeah, so low frequency energy masks it. Okay, so when you do this, so this becomes distinctive with pre-emphasis S. Okay, I don't know how this is working though, how like what's the maths behind it, but okay, cool. So we need this for sure, pre-emphasis filter to be able to do this. That's very interesting. So right, so both sounds invoke racket shuttlecock contact. That's very interesting. So they are talking about badminton particular scenario. Fast, powerful impact, sharp, transient, strong, high frequency content, which makes sense, right? When you smash, there's a tuck sound, and then that's it. Gentle touch, soft contact, mostly low frequency content, right? So frequency over here dominates all features, and net drop also dominates. So you need to have emphasis, pre-emphasis filter, which is very interesting, guys. Awesome. Distinctive crack. Tuck. Okay, now I want to play badminton. Cool. I think we are Okay, so this is good. First order difference, the formula is discrete time derivative approximation, which is essentially, okay, yeah, this makes sense, right? So when you consider this coefficient goes approximating to 1, this is essentially a differentiation of x over time, right? Derivative in continuous time. That's all. So for sinusoidal curve, okay, why does derivative boost high frequencies? For sinusoidal curve, this is what it is. If you try to find a derivative of it, it will be uh, cosine, sine का cosine होता है, and then you will have 2 pi coming outside and f also coming outside. So that's how, great that I remember differentiation. The amplitude is multiplied by frequency. So you have low frequency, amplitude frequency multiplied by 628. When you have high frequency, it's like, of course, they're calculating 2 pi f over here. So maybe that's how it's doing. So for high frequencies, we are basically multiplying them by a higher number. And that's how it's pre-emphasizing. Sounds good, guys? So far, so good. Say hi, say yes, say what's up, say Jai Mata Di, let's rock. Just say something. Okay? There's a song, by the way. You guys should listen to this song. I'll share the link. Say something, I'm giving up on you. It's a nice song. My brother introduced me to this song. Actually, like, he has introduced me to most of the songs, all the good songs, all the Chichora songs. My friends, yes, teacher. So this song you should listen to. It's a very nice song, by the way. Anyway, so we are here in our audio feature. P-emphasis aims to balance spectral energy. Okay, that's enough of frequency, guys. Come on, okay, we are done. So this is how they're. Oh, this is very interesting. They're using numpy.append. Okay, I think, guys, give me 1 minute again. I will have to leave in 2 minutes, but let me just check. All right, guys, I think I'll have to hop off now. I've got some work, but thank you so much for joining, guys. Whoever was here, like we did cover pre-emphasis of an audio filter, so I think we did a good job today. In next stream, we'll continue doing this. Okay, it might happen tonight, it might happen tomorrow, it might never happen again if I die, but overall things are looking good. Okay, so thank you so much for being here, Jaideep, Dev, Nihal, Bhaiya, and Mummy, who is silently always here. So yeah, looking forward to it. See ya. Thank you so much, Bhaiya. Thank you, Jaideep. Thank you, Dev again. Thank you, Nihal. I'll see you again. Bye bye. I'll just do a quick mic drop on the channel. See, this is a mic and this is dropping. Okay. So thank you all. I should stop doing it again. But okay, cool. Chalo. Bye bye everyone. Bye. Take care. Thank you. Nice stream. Thank you. Thank you. Bye bye. Bye everyone.